Just now, next question on register combination. Now there is a question: four resistances of equal value are connected as given in figure, and three ammeters are put in the circuit. You have to find out the ammeter readings. Very simple. Three resistances. Four resistances. This is R1. This is R2. This is R3, and this is R4. These are connected with a 12-volt battery. R1 is equal to R2 is equal to R3. All resistances have equal value. Now ammeters are put in the series. No, not ammeters, voltmeters. Voltmeters are put into series in this way. One is connected here between this point. This is voltmeter. This is connected here. Another, this is say A. This is say B. These are voltmeters. These are voltmeter. This is the voltmeter, and another is put here. C. This voltmeter is put here. C. Now resistances are of equal value. So this 12-volt voltage drop across all the resistances will be the same. Let I be the current flowing through these resistances. Then here is I in the resistance, same I goes to here and comes back here. Now voltage drop between this resistance, this. There are four resistance of equal value. So this voltage drop across all the four in series will be divided. So between this 12 volt is between I1 R1 plus I2 R2 plus I3 R3 and plus I is same. I is same and value of R is also same. So you say all the resistances R1 equal to R2 equal to R3 equal to R4. Say R. Say the value R. Then what will become? This will become 4IR. Then IR is equal to 12 by 4 means IR is equal to 3 volt. Means across each resistance this voltage drop will be divided equally. So what will be the reading? What will be the reading in a voltmeter A? It will be this one, I1 R1. So this will be 3 volt. It is connected between this resistor R2. So this reading will be 3 volt. This is 3 volt. This is 3 volt. Both R plus R 2 watt. Then between this point and this point, voltage drop V is equal to IR. So IR plus IR, and this is 2 IR. So IR is equal to 3. So 2 into 3 is 6. The reading of voltmeter C will be 6 volt. In this way, you can find the voltmeter readings when 4 equal resistances are connected in series. Next, next question. Very interesting. There is a figure, there is a combination of resistances. You see the figure and find out the resultant resistance between point A and B. This is the figure. This is point A. This is point B. Different resistances, resistors are connected in this way. This one 10 ohm, and this one 30 ohm, and this one 10 ohm, and this one 20 ohm, this one 10 ohm, and this one 20 ohm. So what is the resultant between point A and B? You have to find out the total resistance between these 2 points. So what will happen? ध्यान से देखिए, इस फिगर का इंस्पेक्शन कीजिए, विजुलाइज कीजिए, बढ़िया से देखिए और प्रॉब्लम को कई पार्ट में डिवाइड करके सॉल्व कीजिए. Now you see, you cannot add this resistance in series because this comes here. You cannot connect this to this direct in series because this is here. Now take these 2 points, this point and this point. Then this resistance 20, 10 and 20 are in series. So here यहाँ से ये सीरीज, ये तीनों these 3 resistances, this one are in series. The total value becomes 20 plus 10 plus 20 is equal to 50 ohm. Now the figure is modified in this way. This 30, this 10, this is A, this is B, and now comes this one. The equivalent resistance of these 3. इन तीनों को मिलाकर when you add these 3 in series 20, 10, it is 50 ohm. Now this is 10, this is 10. Now you see these are in parallel. So between this point and this point, these two are in parallel. Now you take parallel combination. तो इसका yeah, between this point, 1 by r is equal to 1 by 30 plus 1 by 50. Take LCM 150, here is 5, here is 3. Now it is 8 by 150 r. Now these two becomes 8. 1 by r is equal to, so r is equal to 150 by 8. It becomes 150 by 8. Now the figure comes in this way. This becomes A, this becomes B. This is 150 by 8, this is 10, this is 10. Now all are in series. So you have to find out the equivalent R here. Equivalent R is equal to 10 plus 1 by 50 plus 10. 1 by 50 by 8 plus 10. This is 10 plus 150 by 8 and plus 10. You solve this. You divide by this 2, then is 75. Again 75 is divided by, so it comes to be 37.5 by 2. Now the this figure 18.75. So this is 10, this is 18.75 plus 10. This is very easy. 20, 38.75 ohms. This is your answer. We have followed a long step. You can easily come to this figure. So this is the answer. It seems very tough, but it is very easy. When you break it, break the figure and find the resistance step by step. Now one more question. Two similar bulbs are connected as below. Find ammeter readings. It is very simple question, but you should know, because practice makes a man perfect. You have to practice a lot. Now this is the figure. Here ammeter A1. Here again put ammeter has been put up A2. Here this is a bulb. Here again an ammeter in the circuit. Again they have put an ammeter here. A4. Again a bulb. Again an ammeter A5. This is A4. Bulbs are of equal resistance. One thing is given, then current here, this I is given is equal to 0.5 ampere. Now this is V volt. Ampere is given. Now you have to find out the readings of all the ampere meters. So now here I is this, so A1, this current is passes here. So A1 is equal to 0.5 ampere. Very simple. This is our household connection. Power of this bulb, both are in parallel, is same. So what the current? The current will divide equally in both. So this and this. Here I by 2, here it is I by 2. Any means 0.25 ampere. Now in this circuit current passes, same current comes here. Here it is 0.25. Here it comes 0.25. Here it joins this 0.25, this. Here 0.25, so again this becomes 0.5 ampere. The ammeter reading here, this ammeter reading A2 I by 2, 0.25 ampere. A2 is equal to 0.25 ampere. So this reading is also 0.25 ampere. This is also A4 0.25, A5 0.25 ampere. A1 0.5 amperes and all other ampere meters will show this. This is A3, A4, A5. This is your simple answer. Very simple question. Now we have sufficient time, so इसलिए आज मैं आप लोगों को इलेक्ट्रिक हीटर्स और इलेक्ट्रिक हीट एनर्जी प्रोड्यूस्ड बाय इलेक्ट्रिसिटी थोड़ा सा बताऊंगा. I will make you know about the heat generated by electricity. Heating effect of electricity. Let us see whether it is working or not. Oh, working. Heating effect of इलेक्ट्रिसिटी. ध्यान से पढ़िएगा. मैकेनिक्स और इलेक्ट्रिसिटी में बहुत सी चीजें कॉमन है. प्रिंसिपल इज द सेम इन मैकेनिक्स एंड इलेक्ट्रिसिटी. यू नो, आप जानते हैं, when two metal surfaces in contact move upon each other, means two surfaces in contact have relative motion, they become hot. Why they become hot? Which thing makes them hot? How the heat is generated between two surfaces when they rub against each other. This is the cause is called friction. In mechanics, when two surfaces in contact are in relative motion, they produce heat. Why? The friction opposes the motion. In the same way, when an electric current flows in a conductor, the resistance of the conductor, if the conductor has high resistance, then it opposes the motion of the current. The flow of current is opposed by the resistance of the wire, then heat is generated. In the same way, as the friction works in mechanics, the resistance works in the electricity. Now let this be a resistance of very high value. दिस आर से इज इक्वल टू, मैं वैल्यू लिख रहा हूँ जिसे आपको याद रहे, यू शुड रिमेंबर, so that I am writing that value of the resistance. A material called nichrome, नाइक्रोम से ही हीटर के एलिमेंट्स बनते हैं. ऑल द हीटिंग एलिमेंट्स लाइक रूम हीटर, गीजर, इलेक्ट्रिक हीटर, एमल्सन रॉड्स, हेयर ड्रायर, जहाँ भी इलेक्ट्रिसिटी से हीट प्रोड्यूस करना होता है, वी यूज द रेजिस्टेंस मेड अप ऑफ नाइक्रोम. नाइक्रोम NiChrome, nichrome. Nichrome has very high resistance, 110 into 10 to the power minus 8 minus 18 ohms. No, minus 8 ohms. This is the resistance of nichrome wire. This is called very high resistance. Copper का resistance R copper, it is 1.67. You take approximately 1.7. याद रहेगा, it will be easily remember. 1.8 into 10 to the power minus 8 ohms. Now you compare, this is the copper, very low resistance, it is called a very good conductor. This is called, nichrome has a high resistance as compared to this. You will compare, this R is approximately 60 times that of copper. So when current flows, when you apply a voltage, this is your household voltage, AC voltage, you apply this say this is your room heater having resistance R. Yes, you apply a voltage V, household voltage 220 volt. You have studied about the power, electric power. P is equal to VI. Electric power is given by this equation. Now you know the definition. Work, or you can say work done or energy consumed, is equal to, no, power is defined is equal to rate of doing work. So W by T, where T is the time. So now work done or energy consumed, you here take W or E. In case of electricity, this is power into T, and power into time. So here you go in VI, time T. Now we put the value of VI, so you will find the value of V in terms of R. V is equal to IR ohms law. Put the value of V, so this becomes I square RT. Here this is energy consumed or heat generated or work done by the electricity when passing through this resistance R. So here I am talking about the heat generated by the electricity, so we write here H. Heat. H is equal to I square RT. इसकी यूनिट पावर वाट में है. वर्क जूल पर सेकेंड, ये बराबर वाट. When it is watt multiplied by time, it's become joule. So this is joule. Joules. This equation is also known as Joule's heat law. Joule's law of heating. This equation is called Joule's law of heating. As we are studying heating effect of electric current, so this equation is important. You should remember, should write down, and you should remember it when you study about the heating effect of electric current. H is equal to I square RT. Now, when you solve the problems, sometimes you are given with voltage, sometimes you are given with power P. So you need not to convert all the times V into the form of IR. RP is equal to VI, power is equal to V into I. Yeah, P, you know all the three forms of P. P is equal to VI. Now you take the value V is equal to IR, so this is I square R. If you take the value of I here in the form of V by R, so this becomes V square by R. These are three values, three mode of writing. तीन प्रकार से आप पावर को लिख सकते हैं, इलेक्ट्रिक पावर को, और इसमें टाइम का मल्टीप्लाई करके द हीट एनर्जी की वैल्यू, तो यू कैन फाइंड आउट हियर टी टाइम, हियर टी, हियर टी. So these three equations can be used to find the value of heat, electric heat. Heat is equal to, main equation is this I square RT, but if you are not given I, you are given V and R and time, then you can use this equation. You can use directly this equation to find out the heat generated by the electricity. You need not to convert all the times, that you always find the value of I. Sometimes you are given the value of the amount of charge flow in a given time. In that case, your work is also given by voltage multiplied by charge Q. This is also heat energy. When a voltage V is applied and for a given time charge Q flows through the circuit, then you can get the heat energy directly by multiplying V to charge, total charge flow Q. You need not to derive first. So you find out I, then you have to Q by T, then you have to find R, then you go to calculate HI square RT. Then for competitive examination or tick mark a question, very short question answers, you can use directly this formula for heat generation, and for power also. You need not to calculate all the times I, R. Okay. Let us touch the next topic today, magnetic effect of electric current. आप लोग घर पर खूब प्रैक्टिस कीजिएगा, जब भी प्रैक्टिस कीजिए कंसंट्रेट होकर खूब न्यूमेरिकल लगाइए. You solved a lot of numerical you have to solve. Then the theories, the principles will be clear, crystalline clear when you solve the different type of numericals. Magnetic effect of electric current. You find you have studied that when a charge Q, here is a test charge Q plus, when it is in static condition, it is put here. Then around it, ऊपर नीचे दाएं, left right up down, this side that side, in total space, it produces, this test charge, any charge is associated, it has, this is its effects, that where it is, the space around it has an electric current, electric field, or near this charge the strength of the field is much more, and when you move away from this charge the strength of the field will decrease. In the same way, when this charge flows in a current, in a conductor, that this is a, मैं थोड़ा मोटा बना रहा हूँ, this is the wire, this is the cross section, this is the cross section of the wire. When these charges flow, so many charges, charge Q flows in this conductor, this is a wire, this charge is in static state, here this produces electric field around it. Now this charge under flow, let a current flows in this conductor I. When the current I flows in this conductor, it is found, it is observed that small nails, small iron bits, when put near this conductor, small nails, these are attracted towards the conductor. So it has been observed that when a current flows through a wire, it produces a magnetic field. A force comes into picture which drives these nails towards this conductor. A magnet, a pull force is experienced by these magnetic materials, bits of magnetic materials put near this conductor which carries a current I. This is called the magnetic effect of the electric current. Means when a current you can write in very small words, small sentence, when an electric current flows through a conductor, magnetic field is produced around it. This effect, ये प्रभाव, विद्युत का ये प्रभाव, this effect of electricity means when a current flows in the conductor, the electric field is produced near the conductor. This effect of flow of electricity in a conductor, this effect of current, this effect of this effect the production of electric field, this effect of electricity, this effect of electric current is called magnetic effect of electric current. This effect of attracting the iron nails, this effect of producing a free magnetic field is called the magnetic effect of electric current. It's called magnetic effect of electric current. We see all the materials are not magnetic materials, like woods, जैसे लकड़ी है, पत्थर है, मिट्टी है, पेड़ पौधे हैं, कागज है, अपने आप में मैग्नेटिक मटेरियल, ये प्लास्टिक है, मैग्नेटिक मटेरियल नहीं है. Bits of paper got induced the magnetic material नहीं है. There are some prominent metals which are magnetic materials, जैसे निकिल है, कोबाल्ट है, and one more is iron है, steel है. These are easily magnetized. So these are called the magnetic materials. The materials which are attracted by a magnet are called magnetic material. सबसे बड़ा मैग्नेट आपका अर्थ है. तो दिस इज योर अर्थ. से this is your north pole. It is inclined at 23.5 degrees, so we have, and this is your south pole. आपके पास when you have a bar magnet, rectangular cross section का एक बार है. Generally bar magnet is a simple rectangular piece of magnet. This is a bar magnet. You tie it with the thread and you hang it freely everywhere, catching in your hand. It will always stay. If it is horizontal, you hang it horizontal by tying in the middle of this magnetic bar. It will always hang here in this way. You are here in the northern hemisphere. You are living in the northern hemisphere. So we talk about our country India. if you hang, this is the middle, this is your equator. If you hang this here, this is your magnet, this will always stay here, and this is not pole. So this portion, say this end, if this end comes here and this end comes here, so this is called north pole, this is called south pole. The end towards north has been named as north pole, and this end has been named as south pole of the bar. So why this comes always in this position? Because our earth is a very big material. Inside the earth, magnetic core is filled up. Three parts of the earth. The upper portion is crust, the middle is mantle, and the last one in the middle is called core. This is filled with the magnetic materials, so it behaves like a very big magnet, and that is the reason when a magnet bar is suspended in the air on the earth, it always takes the direction north south. So this has been named the magnetic bar. These are names, the poles of the magnets, in the name of these poles, north poles and south poles. So these end of the magnets have been named as north pole and south poles. Now, magnetic lines. आप बुक्स से लैंग्वेज पढ़िएगा तो और कंसेप्ट, इसके एग्जाम्पल आपको मिल जाएंगे, बट इट इज वेरी इंपॉर्टेंट, वेरी मच इंपॉर्टेंट टू क्लियर योर बेसिक magnetic lines. As name indicates, magnetic lines. This is your magnet. This is your magnet. Say this is north pole, this is south pole. The magnet is put here. Now, surrounding this magnet is present here. So nearby space, it will create a magnetic field. इसका effect, the effect of presence of magnet, surrounding it there will be magnetic field. And when you put a small north pole, it is supposed that you put a smart north pole. वैसे दो पोल, you cannot separate the two poles of the magnet. You will cut the magnet from here, here, here. When you cut from here, it will be in the two part. You cut here, this become north pole, this becomes south pole. You again cut these. This becomes south pole, this becomes north pole, this becomes south pole. How fine you go on cutting, you cannot separate the two poles of the magnet. So we say that assume, आप कल्पना कीजिए कि here, this is north pole, this is south pole. Here at this point, a north pole, a very small north pole is put here. So this is in the magnetic field due to this magnet. And you know that as in the case of electricity, जैसे electricity में समान charges यानी पॉजिटिव चार्जेस एक दूसरे को रिपेल करते हैं, और like charges repels each other, and unlike charges, positive, one positive, other negative, they दोनों के बीच में आकर्षण होता है. They attract each other, unlike charges. North pole, they will repel. इधर को फोर्स लगेगा, इधर को एक दूसरे को दूर ढकेलने की कोशिश करेंगे. रिपेल. नॉर्थ पोल साउथ पोल अट्रैक्ट. एट द सेम केस प्लस क्यू माइनस क्यू, तो दिस विल अट्रैक्ट एक दूसरे को. ये माइनस क्यू है, ये प्लस क्यू है, तो दोनों एक दूसरे को खींचेंगे. अट्रैक्ट. अब प्लस क्यू और प्लस क्यू, तो दोनों एक दूसरे से रिपल्सन लगेगा. रिपेल. In the same way, minus q, they will also repel each other. This force, दोनों पे ये इस पे फोर्स इस डायरेक्शन में लगाएगा, ये इस पे इस डायरेक्शन में लगाएगा, दोनों रिपेल करेंगे. Like poles repel each other, unlike poles attract each other. Let north pole, very small north pole is put here. So what happens? This is in the magnetic field. The effect of north pole here is much more. Let the point is here. The north pole is this. A very small north pole this. This will repel this in this direction. So force on this north pole due to electric field will be in this direction. In the same way here, very small north pole is put here. This will attract. So the force will be in this direction. Similarly here, this is north pole, the force will be in this direction. Why not in this direction? Because this is south pole, this attract this, so this follows the middle path. So in north pole, if it allows to move in the magnetic field, अगर very small north pole को अलाउ किया जाए इसके मैग्नेटिक फील्ड में मूव करने के लिए, तो जो इसका रास्ता होगा, द पाथ ट्रेस्ड बाई द वेरी स्मॉल नॉर्थ पोल इज कॉल्ड द लाइंस ऑफ मैग्नेटिक लाइंस ऑफ फोर्सेस. मैग्नेटिक लाइंस ऑफ फोर्सेस. तो मैग्नेटिक लाइंस ऑफ फोर्सेस आर द पाथ ट्रेस्ड बाई अ यूनिट नॉर्थ पोल. ये तो इधर जाएगा, यहाँ से जाएगा तो कहीं से घूम के आएगा, इधर आएगा. ये लाइन दिस विल बी द मैग्नेटिक लाइंस. यहाँ से इमेनाइट करेंगी, घूम के जाएंगे, निकलेंगे, यहाँ से चलेंगे, वहाँ वापस आएंगे. One thing more, two magnetic fields will try to repel each other. Why? These are the path of force on a unit north pole. So similar pole, there is a force on the similar pole, so they will, two lines will always try to separate. Number two, no two magnetic lines can cut each other. Why? Let a line cut this line at this point, goes in this way. What happens on this point? When we put the north pole here, what is a magnetic line? The path traced by a unit north pole in the magnetic field. So what happens here? अगर नॉर्थ पोल स्मॉल नॉर्थ पोल है, तो इस पे फोर्स जिस नॉर्थ पोल की वजह से एक ये हो जाएगा, एक ये हो जाएगा, अगर कट कर रहा है. तो देयर कैन नॉट बी two directions at a point on the small north pole. So two magnetic lines never cross each other. Okay, students, today I stop here. Further, I will take one by one all the chapters of the physics, and in between these lectures are, you can say, tuition or teaching. I will load some numericals. I will also show you solving the numerical on the board. But I request you that you have to practice and practice more and more. And you have to revise. I am I am telling you in all our lectures the method of revisions, that first revision should be between 2 weeks and third revision should be between 30 days and 45 days. Thank you very much.